Hey chemists, welcome to our last day of pH lessons. Today we're going to be focusing on talking a little bit more about the pH scale and what that really means in terms of both hydronium and hydroxide ions. So let's go ahead and dig right in. Okay, first thing that I want to do is I want to just go through and give the relative concentrations of our H3O plus, our hydronium ions, or our OH minus or hydroxide ions. Now, remember, we've talked a little bit about this already in class, but we know that the exponents of our two concentrations of both hydronium and hydroxide must add up to times 10 to the negative 14th. So let's go ahead and start with H3O plus, since I think that that is going to be the easiest. So our concentration of H3O plus at a pH of 1 is 1.0 times 10 to the negative 1. So just to keep things nice and neat, I'm just going to put 10 to the negative exponent value, but if you want to write the full number in there, please feel free. Okay, now if this is our concentration of H3O plus and our sum of our two concentrations must be to the negative 14, that means our concentration of hydroxide at this pH is 10 to the negative 13. Okay, let's go ahead and do our next one. pH of 2, 10 to the negative 2 for hydronium. Hydroxide would be 10 to the negative 12. Okay, for our pH of 3, hydronium concentration 10 to the negative 3, hydroxide concentration 10 to the negative 11. Now, something that I want to kind of just quickly show you guys, as we're going from 0 to 14 up our pH scale here, notice that our hydronium is becoming less and less concentrated. Okay, it's becoming less and less concentrated, and our hydroxide is becoming more and more concentrated. And I know that sometimes this is really hard to kind of wrap your head around, but because the values are getting, bigger for H3O plus, sometimes we start to think, or they are getting bigger for H3O plus, we sometimes start to think that that it's increasing, but 10 to the negative 1 is actually larger than 10 to the negative 3. All right, so on to our next value, 10 to the negative 4 for our hydronium concentration, 10 to the negative 10 for our hydroxide concentration. Okay, for 5, we have 10 to the negative 5th, and we have 10 to the negative 9th. For our pH of 6, 10 to the negative 6th, 10 to the negative 8, and then we hit our beautiful neutral spot here, 10 to the negative 7 for both, right? At a neutral pH, we have equal concentrations, and I'm going to write that in just a moment. Okay, for our pH of 8, okay, we have 10 to the negative 8 of hydronium, 10 to the negative 6. Okay, for our pH of 9, 10 to the negative 9, 10 to the negative, 5th. Okay, and moving forward still, we have 10 to the negative 10, 10 to the negative 4, and so on and so forth. So I'm just going to keep writing these here. We have 10 to the negative 11, 10 to the negative 3. Okay, we have 10 to the negative 12, 10 to the negative 2. And then lastly, we have, or not lastly, 10 to the negative 13 and 10 to the negative 1. Now, we haven't actually in class or in any of our Edpuzzle videos talked about pH of 0 or pH of 14. So we can figure this out, at least for the hydronium concentration for 10 to the negative 14 for a pH of 14. So I'm going to go ahead and put this in, let's see here, maybe this gray color. So we have 10 to the negative 14 here. If our exponents have to add to negative 14, then that means for 14, I am going to have 1.0 times 10 to the negative 0, which is the same thing as just saying 1.0. So if I have a pH of 0, then my concentration is just 1.0 molar, and my concentration of OH minus would be 10 to the negative 14th. So now we can see our full scale here. Just a couple things that I want to kind of tie back into this conversation here is just this idea that when we are below a pH of 7, okay, and I'm just going to kind of highlight that by circling here all of these below that pH of 7, these are all considered acids, okay? And what makes a solution acidic is the fact that it has more hydronium than it does hydroxide, okay? So these are acidic pH values, okay? And they have a greater concentration of H plus or H3O plus compared to OH minus, okay? And so as we are going from left to right across that pH scale, notice that I have two arrows here. I want to focus on this bottom arrow here. As we're going from left to right across the pH scale, our concentration of H3O plus is decreasing and our concentration of OH minus is increasing. So as we go from, actually, let me put this below the line so I leave myself some space. So as we go from 0 to 14, okay, on the pH scale, our concentration of H3O plus is going to decrease, okay, and our concentration of OH minus is getting bigger. And it's going to continue to do so until it reaches that pH of 7, which I just mentioned is our neutral pH, okay? And it's a specialty point because it is the point at which we have equal concentrations. So this is our neutral pH. And again, our concentrations are equal. H plus is equal to OH minus, okay? And then that leaves us at a pH above. And again, this is going to be the point at which we have more OH minus than we do H plus, okay? So let's go ahead and just circle or highlight that here so that we are clear, okay? And so here we have a basic pH, okay? And again, our concentration of H plus is less than our concentration of OH minus, or you can think of it as OH minus is greater than H plus. So as we are going from our pH of 14 down to 0, we can think of it as the opposite as we are going from a pH of 14 to 0, as we go from 14 to 0, okay, the concentration of H plus or H3O plus is increasing and our concentration of OH minus is decreasing. And I'm putting these on this sheet because it can start to get very muddled, all of this increase in pH versus decrease in concentration, et cetera, et cetera. So there's a lot of increasing and decreasing going on. And actually, thinking of that, I actually want to put that right here at the very top. So this can be a little bit confusing, and let me make this a little bit bigger, okay? But as you increase in pH, okay, as you increase in pH, as pH increases, okay, the concentration of H plus decreases, okay? As pH decreases, okay, as it gets closer to 0, the concentration of H plus increases. So these two things, as long as you can remember that as one is increasing, the other is decreasing, you're going to be good to go. Now, this leads me to kind of the last part of pH that we have to talk about, which is how these numbers all kind of interconnect. So I want to take a moment here and think about just going from, let's say, a pH of 0 to a pH of 1. How many times less concentrated is the H plus Or going rather from a pH of 1 to 0, how many times more concentrated is it? So if we're comparing a pH of 0, right, a pH of 0 or a concentration of 1.0 equals a pH of 0 versus a pH of 1, which is 0.1, how many times different is this value? Well, this value is going to be just 10 times different, right? If we're thinking in these powers of 10 times different. So let's go ahead and talk about relating this down here on our pH scale. If I'm going from a pH of 1 to 0, okay, it is 10 times more concentrated. Okay, it is 10 times more concentrated. And again, this is all in terms of H3O plus or H plus. Okay. What about now if we go from a pH of 2 to 0? How many times more concentrated is this? Well, again, think about our values, 10 to the negative 2 compared to 10 to the negative or 10 to the 0. Okay, so if we're comparing that, it's really the same thing as saying 0.00, or I'm sorry, 0.01 versus 1.0. What's my difference here? This is going to be 100 times different. So every numerical value of pH is 10 times different than the next. But if we're talking about comparing things that are 2 or 3 values away, that's going to be compounding. So if I'm 2 values, 0 to 2, instead of being 10 times different, I'm now 100 times different. So this is going to be 100 times more concentrated than that pH of 2. Okay. And lastly, what about going from a pH of 3 to a pH of 0? Well, are we picking up on the pattern here? 3 to 0 is going to be 1,000 times, becoming 1,000 times more concentrated. Okay. So again, if we're talking about going from 3 to 0, the pH of 0 is 1,000 times more concentrated than the pH of 3. If the pH of 2 to 0, the pH of 0 is 100 times more concentrated than the pH of 2. If I'm talking about a pH of 1 to 0, the 0 is 10 times more concentrated than the pH of 1. All right, now let's talk about going the opposite direction. Let's talk about going from, instead of going from high numbers to low numbers, let's go from lower numbers to higher numbers. So let's first talk about going from a pH of 5 to a pH of 6, okay? So a pH of 5 to a pH of 6. What's my difference? And again, be careful because we're always going to be talking about in terms of H3O plus. And this is where it comes in handy. If I'm going up in pH value, then what's happening to my concentration of H plus? My H plus is decreasing. So going from a pH of 5 to 6, I'm still 10 times, okay, but am I more or less concentrated in terms of H3O plus? So if I'm going from 5 to 6, I am 10 times less concentrated in terms of H plus. Okay. What about going from a pH of, let's see, 4 to 6? Okay, 4 to 6. I'm going to be 100 times less concentrated. Again, a pH of 4 has 100 times more H plus than a pH of 6. And lastly, what about going from 3 to 6? Okay, I am 1,000 times less concentrated in terms of H plus. Okay, so this is the tricky part, or the trickiest part in my opinion, about the pH scale. So let's take a look at some practice problems. Compared to a 1 liter aqueous solution with a pH of 7, a 1 liter aqueous solution with a pH of 5 contains how many more times hydronium? Okay, so a pH of 7 going to a pH of 5. So my difference is 7 to 5 is 2 pH values, which means that I am going to have 100 times more hydronium. Okay. Question 2. Compared to a solution with a pH of 7, a solution with 1,000 times more, okay, so we're talking about more hydronium, will have a pH of what? Now, here's where it gets a little tricky. I have a pH of 7. I want to have 1,000 times more hydronium. So there's 2 options of what could happen here, right? I have 7. I know that if I'm 1,000 times different, then I'm different by 3 pH values. So I could be talking about going to 10. I could be talking about going to 4. So I need to think about it now in terms of hydronium. Which way has more? Okay, more is the keyword hydronium. Okay, again, as we are going from 0 to 14, hydronium is decreasing. So this would have less hydronium, which means this would have more hydronium. So correct answer here would be a pH of 4, not the pH of 10. And our last question here, okay? A blank times increase or decrease in the H plus ion concentration represents a decrease of 1 unit on the pH scale. So first and foremost, if we're talking about 1 unit on the pH scale, before we talk about whether we're going up or down, how many times is it 10, 100, 1,000, 10,000, 100,000? Okay, if we're talking about 1 unit on the pH scale, how many times different is that? Okay, that's only going to be a 10 times difference. So a 10 times increase or decrease in H plus represents a decrease of the pH scale. So let's give ourselves just an example here. Okay, if I'm going from a pH of 2 to 1, am I getting more or less hydronium? Okay, I am going to have an increase. Remember that as pH decreases, okay, so as pH decreases, hydronium increases. So I wanted to write that below it, but I'm running out of space. As pH decreases, hydronium increases. All right, have a great day, everybody. I will see you tomorrow.